Okay, we're on problem number one. It's a limit problem. Looking at it, looks like we'll have to use L'Hopital's rule to do it. At least that's the easiest way that I see the problem number one is to do L'Hopital's rule. So I'm getting 0 on top, and I'm getting 0 on the bottom. So let's go to whiteboard and write it down. And what's the limit going to be? Get the sheet of paper out again. It's number one, and this is limit x goes to 1 from the right side, and then it's got x to the x power minus x. On bottom it's 1 minus x plus the natural log of x. All right, I'm going to say use L'Hopital's rule. I put an h over the equality indicating I'm using L'Hopital's rule, and then write down the limit. I'm going to take the derivative of the top and of the bottom and see if that limit exists. On the bottom it's pretty easy. You get minus 1, and then you get plus 1 over x. I'm just going to write down x to the minus 1, a little more compact to write that down. The top's more challenging for me, and I want to go through that with you. So I need the derivative of x to the x. I do that by taking logs of that. It's called logarithmic differentiation. That's x ln x, and 1 over y, dy dx. It's going to be a product rule. It's going to be the natural log of x, and then it's going to be x times the derivative of natural log, which is 1 over x, so plus 1. So dy dx would equal y, which is x to the x, and then you get ln x plus 1. All right, took John to do that, but I got that part done. I'll write this over here for you. So I get x to the x, ln x, I'm distributing, by the way, plus x to the x, and the derivative of minus x is just simply minus 1. Now I got trouble again. The trouble again is I'm looking at this over here, and as x goes towards 1, the bottom goes towards 0, and the top also goes towards 0. So I'm going to use L'Hopital's rule again. It gets more complicated as we move forward, right? The limit, x goes to 1 from the right side. The bottom's limit is pretty easy. It's simply going to be minus 1. The derivative of minus 1 is 0, but I'm doing derivative of x to minus 1. And then you get, what do you get there? You get x to the minus 2. Write this over here. Now it's more and more challenging for me. I'll get my eraser out. Actually, I'm not going to get the eraser. I'm just going to write this, the top, I want to take its derivative. It's x to the x, and then write down natural log of x plus 1. I am going to rewrite that. It's still going to be a product rule, by the way. And I'm going to say x to the x times the derivative of the inside there, which is, I shouldn't say the inside, the next factor, which is ln x plus 1, which is 1 over x, plus the derivative of x to the x, which is x to the x, ln x plus 1, times the second function, which is ln x plus 1. So I'll put squared down here. And then it's going to be, let's see, plus, well, it's getting really complicated, isn't it? I just did this one. Now I'm doing this over here. And that's going to be, let's see, x to the x, and then ln x plus 1. Wow, is this thing ever going to stop? Well, let's take a look at this over here. And it doesn't look that bad, actually. And I'm going to see if I can do that, as it's written, by the way. I want to be careful about this. And I'm looking at that, see if there's anything else I can do with it. Let me make sure I did the derivative right. I would say that things are getting really complicated right now. But let's see. I got this part done. And I got this part done. Let me see if I did that right. It's the first function under the second, which I got that. And then the, I think I made a mistake. I get my eraser out. And I'm looking at this and I think I made a mistake somewhere, so I'm going to erase this and start again. All right, so let's write this down again. So I'm taking derivative of the bottom. That's not my problem, by the way. That's minus x to the minus 2. The top's more challenging for me. And let me just do one thing at a time, by the way. I'll do the easy guy. I'll do this guy first. All right, what do you get there? You get x to the x times the natural log of x plus 1. Right? This guy's easy to differentiate, just simply 0. I'm not going to write that down, by the way. And this is more of a challenge for me over here. Well, let's write this down. So it's going to be plus x to the x times the derivative of natural log of x, which is 1 over x, plus the natural log of x times the derivative of x to the x, which is x to the x, times natural log of x plus 1. That really does look nightmarish, doesn't it? I'm going to try to simplify it a little bit and limit x goes to 1 to the right. The bottom is not much I can do about that. That's all that is over here. And kind of looking at it, I'm going to try to take these two things here and bring it together. Is that worthwhile, though? Well, I get x to the x, right? And then I get natural log of x plus 1 times 1. That gives me that. And what do I get over there? Oh, look at that, natural log of x. So not so bad. And then what do I get over here? X to the x and 1 over x. Let me keep moving along with this. I'm just simplifying at this point. And you get x to the x, then you get natural log of x plus 1 squared plus x to the x, 1 over x. And I think I can plug in now. All right, what do you get over here? On the bottom, you just get minus 1. On top, you get, 1, and then you get 1 squared. That's not so bad. And then plus 1. So what do you get over here? You get 2 on top, minus 1 on bottom, you get 2. And again, we use L'Hopital, minus 2. You get L'Hopital's rule for that one. Again, that's the way I saw the problem. You might see a different way of doing it, but the limit's minus 2. Thank you.